Welcome, everybody, to another edition of Shape Shorts. The last 3 episodes, I did the I-6 as applied to the humanities and the arts. Our next episode, Tony Patuca will do it as applied to science in space, time, and matter. The only problem is he's not here. These clocks are a mystery. He knows a lot about time, but he can't tell time. We've always said this. Oh, I think he may be out there. Patuco, get in here.
Hey, Stu, how are you? You're my spot right here. I'm supposed to be doing this lecture today.
Well, I had to cover for you because you were not.
Well,
you're not here on time. You don't see what time it is.
I'm always on time.
No.
I'm always on time.
You're never on time.
Well, we'll debate that at another issue. But today's going to be an I-6 for science. I heard you say.
That's exactly right. You're up.
I'm up.
Now, I want you to do something. Try to be a human. I know it's hard for you, but try to be a human.
Well,
will you?
we are lucky to have a couple of students here today.
Okay.
And I brought them in so that it's much nicer to see what it would be like if we were in class, right? Look with humanities. When you did humanities, we had your nephew and a few other students were in there, right? Yeah. And so I brought a few students in. They're sitting in the area over there.
Too bad, folks.
Yeah, well,
there's one of the nerd students.
There's the gallery. There's the gallery. The peanut gallery. Give me the razzing. In any case, okay, I think I'm ready.
Yeah, and it was. So I say to you students, good luck to you. And do you have something to keep yourself awake? You're going to need it.
Well, you're going to be, when you fall asleep, don't snore because you can hear you snoring through a concrete wall about 4 feet thick.
That's why I'm leaving.
Okay. Well, hello everyone, and thank you so much for joining me today for a lecture on the first day of physics. Now, technically, in talking to students, they have gone through some mathematics, they've gone through a series of coursework, and their first course in physics is usually a nightmare in their own minds because when you hear the word physics, you begin to panic. And we all do that. It's highly mathematical. It has these weights and pulleys and inclined planes. Probably the most boring subject in all of the university is probably that. So you come in with a great preconception about what physics is. So when I was teaching mostly engineers and physics majors, I really wanted to engage the students, and using the I-6 as Stu and I had spoken of earlier, tried to make it more of an animated environment, one that would rejuvenate the ideas of physics. But the first thing I would say would be, welcome to class, of course. I go through the curriculum. I go through all that we'd have to do to get through the courses. And then we start getting into content. Now, usually the content would be professor turning to the blackboard and developing equations and all kinds of ideas. But I wouldn't do that. My idea was to get the students heavily engaged in the foundational ideas of physics. Now, the foundational ideas are obvious, and that's the problem. And I would always say to the students, and the students that are out there, that are even in our studio today, you're lucky. You're taking a course that's going to define and try to understand the universe. Put in that context, it's not just a course about one thing, it's a course about everything. That's why when you come to class, you have the look in the eyes of the students of great expression and interest. What do you mean by understanding the universe? I'm here to get a degree in engineering. And in a sense, that's fine, but understanding the universe is a huge, giant job, if you think about it. Well, let's start off with the ideas that I would bring out. The first idea is about commonsensical ideas. It's commonsensical for us to believe and to have a whole opinion about, let's say, a window opening or closing if it's raining outside. It's commonsensical to close the window. If you like the rain, you might even open the window to get the sound of the rain. But it's commonsensical. It makes sense to do that. Tying a shoelace has a purpose. Keeps the shoe on. So there's no question about what is a shoelace. But what are the foundational ideas that constitute our understanding of our universe? Well, there are three: space, time, and matter. Now, in this first video, I'm going to discuss only one of those commonsensical ideas, the commonsensical idea of space. And it's so commonsensical, no one's going to question it. So when I ask the audience out there, can you define space for me, what it means, what it is? And I start asking those kind of questions and getting the students engaged, and I will get all kinds of answers, making sure the students get heavily engaged. And when that's the case, I find all kinds of vocabulary words that they begin to use. And they also become commonsensical. Oh, space is the distance between 2 points. Oh, that's fine, except what is distance? And if I don't know what distance is, I'm using an expression to define something I don't understand in the first place, which is space. So let's do a little experiment. Let's just hold out our hands like this. Right hand, left hand. And I not observe, don't sense, don't have any kind of tactile experience with this that I call space, but I sense that it's there. It's commonsensical. It's at the point of being completely understood. And everybody believes they understand the same thing. A separation of two objects in space. And I'm now using the word space to define space. So we understand the conundrum. How do we define space? How do we understand space if we really don't have a definition of it? So at all points of confusion at this stage, I'll ask students to give me more, and they do. Space is the measure between an object and another object. Well, again, the problem with the word measure. Measuring what? I know I can measure space. I can take a ruler and I can measure the distance between my two hands. Maybe it's 1 foot or 1 meter. It doesn't quite matter. But when I ask you, what is that 1 foot actually measuring? That's a different question. That's a question of measurement of space, not what space actually is. Now this brings us up to our knowledge about geometry, the way we view the world. The first individual of many, actually, I'll declare the first because history has done that, was Euclid at about the 3rd century BCE. At about 300 BCE, Euclid, the Greek philosopher, mathematician, 2,500 years ago, came up with the same questions. If I'm going to define what space is, and I use the phrase distance between 2 points, he's going to have to say, what is a point? If I'm going to have 2 points and measure the space between the 2 points, that's fine, but what is a point? So he comes up with a remarkable set of postulates. I'm going to call them postulates. A postulate is an axiom or a common belief, the common sense notion. What is a point? A point is that which has no space. It has no dimension. Again, the word dimension has hiding in it the word space. The three-dimensional universe, the 2 dimensions of a tabletop, the single dimension of a ruler. All these things have a concept of space inherently built into it in a commonsensical way. In fact, Euclid would say what a point is an entity that I cannot even describe to you physically. Once I put a point on a piece of paper as a dot, I've lost the concept of a point because that dot has dimension. It has some kind of occupancy of space. And as a result, we begin to realize a point is only in our mind in this context. So at this stage, I'm going to ask the students that are out there in this studio and out there with you, close your eyes, and I'm all going to have you think the word point. Open your eyes. I don't know what you saw. I haven't got a clue what the mind's eye saw, but I have the uncanny impression that whatever I saw and whatever you saw were the same things. This is an assumption. How do we know that? Then I even get more dramatic with space. I say, well, I have 2 of these undefined objects called points. And now I'm going to measure a distance between these 2 points with the concept of straightness. And you've all heard the phrase, the distance between 2 points is a straight line. Well, what does that mean? Well, Euclid's made it very clear in a commonsensical way that If I draw a line that has no curves in it, no nooks and crannies in it, then it is in fact the shortest distance being a straight line. Again, a remarkable assumption. And we all kind of hold that belief that if I want to get from point A, again, a dimensionless idea, point A, to point B, I should go the shortest route, which is a straight line. With you hiking or driving or flying, it doesn't quite matter. It's a straight line in your mind's eye. But what does the concept of straight mean? In fact, what does the concept of line mean? And that gets even more interesting. And since space is the foundation of our universe, and we all seem to understand it in a common sense way, what actually is it? So let's discuss some of the problems that we might have with this. One problem is I have a straight line between 2 points, and I can fathom, I'm going to use your common sense, I'm going to hold to that belief that you're seeing the same thing I am. Okay, I'll hold to that. However, how many points make up that straight line? Well, now you get a problem, because if there's an infinite number of points, which Euclid would say, between two fixed points, then I have a dimensionless entity, an infinite number of them, lining up next to each other, each one dimensionless, which means I cannot measure them, and yet they add up to a finiteness in length. Again, length, another obtuse word for distance or dimension or space. You see the problem that we have. The problem is we haven't defined space. We've defined maybe how to measure it with a ruler. We came up with an idea of straightness, and we came up with an idea of point. And each of these ideas is, in effect, unknown to us by pure definition, other than what we call a postulate or an axiom, a mechanism of belief. It's a belief system. So when you go into physics in day one, and you say, we are going to talk about the universe, which is space, you see the problem that we have. Foundationally, physics needs to understand the concepts that we hold to be in the realm of common sense, that we all believe, that we all see. One of the problems that we have with this is an interesting one. Xeno, another Greek philosopher, same time period, a little later actually, had come up with an idea and said, how do I get from point A to point B? Well, pretty simple. I walk to a certain point, and then maybe that's half the distance to a door, let's say. I walk another half of that distance to the door, and another half of that distance to the door, and another half of that distance to the door, and by all rights, a half of a half of a half of a half has no end. It goes on infinitely, but yet I get to the door. By all rights, I shouldn't be able to get to that door. I have to go through an infinite number of halving of the lengths to get there. So therefore, space is finite in its length, but somehow there's an infinity attached to it. Now, the analogy I usually use with Stu Barr, since he likes money, is the following idea. If a point has no dimension, and I have an infinite number of them, and I make up a finite line for this, why not go to the bank with that idea? I have nothing in my bank. I've got zero, but I got an infinite number of zeros in the account. Well, it adds up to $1 million. A zero plus zero plus zero plus zero out to infinity must be $1 million. By the way, it can be any value I want. By $1 million, I'll make it 10 billion. How's that sound?
Sounds good to me.
Yeah, I knew Stu Barr came back. When they hear me talk about money, he came back in.
Yeah, I did.
Anyway, the idea is that this becomes a complicated idea. Now, that concept of how we can get out of what we call the Xeno Paradox, how, in essence, does let's say you've all heard the tortoise and the hare story. They both are starting at a particular point. They're going to race down a track. We all know that a turtle is somewhat slow, a hare, a rabbit is somewhat fast. And which one gets to the end? Well, if you go to Xeno, none of them get there. None of them get there, because they all have to go a half distance at a time to get there, and they quite never make it. So then no one is going to reach the end of the line. This is a common problem, would not be resolved until much later in our history. It won't be resolved until roughly 1840 AD. which is quite fascinating that it took that long for the human mind to come up with a picture that is rational about the concept of dimension and distance. It still did not address the fundamental question of space. So in effect, you're here today in this class to talk about the universe. And I have to start with the concept of space based upon what I believe you understand. And what I believe you really firmly hold to be true, in the faith that the distance between 2 points is not only space, but it's a distance of a straight line. And then I extend that to the universe, and that every point in the universe is occupying nothingness. And that's disturbing, because how does a universe exist in that particular context? That it, in essence, is made of these points that have no dimension. And yet, we hold to belief that it's there. Now, I'm going to take it to one level before I leave, and that is this. I want you to fathom that you are in the middle of space. There's nothing around you. There's nothing around you at all. You look up, you see nothing. No stars, no earth. You have a sensation of sight, but you don't know what you're seeing because there's no light. And you begin to extract away from you all your senses. And eventually, what do you begin to conceive? What do you see? What do you believe? Is it space? And when you get to that point, you start to realize that when I extract all the sensation away, I don't sense space. I don't smell space. I don't have any tactile sense of space, but I know it's there. And now I think we'll come back for lecture 2, when we talk more about the concept of another commonsensical idea called time. See you then in the next video on time and how I can confuse you further. Thank you.
All right, everybody, welcome back. We just heard Tony talk about, what was that again?
Space.
I fell asleep.
I knew you were
Space.
asleep.
Right.
You didn't snore.
I've heard this story for 30-some years. I was 40 years. I don't know, whatever it is. Anyway, let's look and see how the I-6 applied to it.
Let's review the I-6, though, just for the heck of it. You know,
We don't have them in front of us, Tony. How can we review them?
You know them. Originate.
Yeah. Here you go. You want the paper?
We all know it. We all know it. To animate, to originate, to rejuvenate, Deus Ex Machina, tell the story.
And simulate.
And simulate.
Yeah. Now, when you talked about, we can use animate, when you said understanding the universe, you animate, you tell a story, everybody's curious about the universe.
Right.
Little kids, well, I should say everybody until they're 6 or 7, then the school system kills that. But anyway, we won't go
Curiosity
into
dies.
Yeah,
Exactly.
curiosity dies. We won't go there.
Exactly.
So you used animate to try to get people, it was a good example of using animate to get people involved, to get a student involved, and it's not just an abstraction. It's something you think about.
When you do philosophy, we both talk philosophy. The same thing happens in philosophy. You get very abstract ideas.
Yeah.
And when a talking head just maintains an abstract idea.
Yeah.
But once you get the student involved to say, answer the question,
It's
then it's wait a minute, I'm on stage now.
Yeah.
What do I say? I say, and then it comes to my head, right?
Right. And then when you said to tell the story and stimulate, you did something that's real easy and very common. What is this is a distance. Well, that's space. What is space? Words we take for granted, we never really define. We don't really think about. We just say the distance between here is X amount of feet, meter, whatever measurement makes you happy. But you call it space. So what is space? By stimulating, you made them hold up. I saw you hold up.
Yeah.
You were always good. I have to give you credit. I hate this. I don't want to do this, but it'll go on record. I have to give you credit for always making things. You get them interested by making them do the silliest things that have the most profound impact on what they're doing.
I send them out of class and I say, bring back a stick.
Yeah.
Just go to our school is in a very nice desert setting, and I'd say, just go find a stick and bring it back. Yeah. And this is going to be your length. And everybody would bring back a different length, a different stick. And I'd say, now, which one is going to be the stick? Yeah. Right? And you don't even know. So that look of confusion, then suddenly start realizing, wait a minute, what have I accepted?
You've just accepted this.
You accepted this one stick
as
the unit of a foot for measuring space.
So now, then I saw originally Euclid in geometry. People have been quoting Euclid, don't even know they're using Euclid. They have no concept of it, but the idea of a point being that which occupies space, and space is what a point doesn't have.
Exactly right.
And as you said, 0 multiplied by some number equals a number?
Yeah.
What second grade arithmetic class did you fail to come up with that?
0 plus 0 plus 0 plus 0 equals 1.
And you were right about me. I did come in then, because when I heard that I could have 0 in my account and turn into $1 billion, you know what? That's a great investment.
And
How do I get
that's
that?
why you've had at least 20 different accountants over the past 30 years, am I right?
Well-
1 a year almost.
Well, they come and go. What can I say?
It's about how many wives you've had.
No, it's 21.
Yeah, but you're right. A lot of people, particularly students, when they come in, they've heard the name Euclid.
Yeah.
But he came up with 5 major. I'm going to talk about one of the postulates today. But 5 major postulates. The 5th one, the one that was the most historical one, is fat. We should do a podcast
just the whole thing on
just
parallel lines.
On parallel lines. But the 4 major postulates constitute the common elements, and he calls it the elements, or we call it the elements of Euclid. He didn't mean by elements, it's the common notions that we have, and that was the subtitle.
And you then end up creating this. Now, the last one, rejuvenate, applying the humanities, the tortoise and the hare.
Right.
How do they catch up? If there's an infinite series between the tortoise and the hare, no matter what speed, the hare can never catch him.
Exactly.
But it doesn't make sense, because empirically, obviously, it does.
And it doesn't even matter if the hare has an advantage of 2 or 3 feet, let's say, in front of
the tortoise.
the tortoise.
It's a little hard, I know.
A little
It's
hard
hard
to
to remember that 5 seconds
well,
ago.
I'd like to call it a turtle. One of my favorite creatures is a turtle.
I know.
They kind of look at me, and then I can lecture.
They recognize a familiar face.
Well, probably. But they actually listen. I talk to the turtles, and they listen.
That's a unique experience.
Exactly.
Anyway.
But you're right. You can give one an advantage,
Yeah.
and they still
Always will have the
always
advantage.
have. They'll never get to the end.
And so, anyway, everybody, I just want to see, this was a good example of how some of the I6 are applied to something that no one would think it belongs into.
So we went through.
We had the animate, tell the story, stimulate, originate, and rejuvenate.
And
we didn't do a Deus Ex
This Machina is pretty much, it could be hidden in there, only in the sense that it's an unusual solution to a very complicated problem.
And it introduces
the unusual solution was the axiom.
Yeah.
The postulate
that has no empirical.
Well, thank you, Stu. Thank you.
Anyway, see you next time for the next one he does.
Which is going to be on?
I have no idea. I don't remember. You're doing it. You change your mind all the time. How would I know? What do you know?
It's on time.
Oh,
Which
well,
you don't
one thing
have.
you don't have. Anyway, thanks everybody.
Stu.